So we're going to talk about MapD and GPUs, and this is going to be a fairly technical presentation with a lot of hands-on, like demos, and I'm going to do some live demos. But before I start, I wanted to kind of get an idea, how many of you work on projects or products that deal with GPUs? Okay, very good, quite a few. And you're not all working for NVIDIA. Okay, awesome. And how many of you are familiar with MapD? Okay, so at least a few hands. That's very impressive. Thank you. And so as we all are living in petabyte data economies, right? Dealing with a deluge of data, and so we have solved the problem of storing it, and also even analyzing it, provided we don't have to analyze it fast. The real challenge comes when you have a lot of data. We're talking about databases with hundreds of millions and billion row data sets, and you want to analyze it fast. And that there is a computational gap, and with all the tools that we have today, both from a visual analytics point of view as well as in-memory database, they're really not adequate to address the problem. And the main challenge is that the innovation on CPUs is not keeping up with the amount of data that is growing, and also the speed at which you want to analyze and get results, right? And so there is a solution, and the folks in deep learning, they've already figured it out. They all are kind of using GPUs, and so GPUs, especially the general purpose GPUs, are designed inherently quite different, right? They were designed to basically render graphics, which is inherently a parallel operation, because when you want to compute the color of a pixel, it can be done independent of a neighboring pixel, right? So now, when you are strapped for computational power, analysts generally resort to all kinds of awkward workarounds. They will actually run queries for which they know they're going to get responses quickly, and or they may downsample, in which case they are going to miss out on outliers or long tail events. You tend to do pre-aggregation or pre-indexing, which again is not a flexible option, especially when you have large data sets. And also scale out, as we have all dealt with it, where scale out computations doesn't really give you good return on investment, because it's complex to set up and keep it running. So GPUs are a great solution. And MapD is an extreme analytics platform that was designed ground up, basically trying to harness the power of GPU to be able to run queries really fast and also to visualize them. And we are talking about large data sets, like multi-billion row data sets. And we will see a demo very shortly where we will actually go through a very large data set. And MapD, as you can see from the picture on the, it basically consists of MapD core. That's a columnar database with an SQL engine. And you have MapD immerse, which is the user interface. Basically, it's an visual analytics platform that makes use of the MapD core database. And now MapD as a database is rarely used as a system of record. So it fits in very well with existing data warehouse solutions, be it Hadoop, be it HANA, or other solutions. So it basically it'll sit alongside your existing system of record infrastructure and allow you to ingest this data as a hot cache so that you can run your queries and visualize it. So as we were saying, the MapD core is the backend portion, and one of the reasons why it is so fast is because we have actually invested a lot in optimizing the SQL analytic operations like filtering, which uses the where operation, or segmenting, which uses the group by operation. In addition to that, we also use LLVM. LLVM is used to basically take your SQL query and compile it into an intermediate code, which is not hardware dependent or backend dependent, and then it is later on just in time compiled based on a specific backend. So it can be compiled for a GPU or a CPU x64 or ARM platform. Now this is actually gives you basically it's very efficient in terms of making use of the memory bandwidth on the GPU, as well as running your and also basically from a caching perspective. Now talking about GPUs, one of the advantages of GPUs, we have thousands of cores, right, compared to the CPUs, even though they do specific or much more simplistic instructions. Now, what we do at MapD is take most of these queries and vectorize it. So by vectorizing it, it basically allows us to the GPUs to run and access these data points in parallel. And that's where we get another big boost in terms of performance. Also, GPUs, in terms of memory bandwidth, they are in the order of terabytes per second as opposed to gigabytes per second compared to CPU. So there again, MapD tries to keep most of the data in GPU memory. So we try to keep most of the data, when you are trying to run queries, we try to keep most of those columns in GPU memory. And so this again and because we use our backend GPU also for rendering, there is actually no copy. So we can immediately create basically a PNG and then transfer to a front-end visualization. So it gives you instant update in milliseconds. As far as our front-end visual analytics tool, Immerse, the cool thing about Immerse is we support very complex charts like scatter plots, point maps, GIS, rendering, and these are actually supported with billions of points of data. And at the same time, on the same dashboard, we also support very simplistic charts like your pie charts, your line charts, your bar charts, the typical charts that you're mostly familiar with. Now, having both the complex charts, and the simplistic ones all on the same dashboard basically gives you multi-dimensional insights into the data. So you can actually slice and dice your data, and you can discover basically features that was probably not possible. One of the reasons why it is so powerful when you can actually do this kind of a query on live data almost in real time is now you're free to kind of explore it and you are getting response almost instantaneously. and we'll see that. Now the way that works is you have to run, say, a filter operation, like a where operation on, say, billion records. What we do is we send this data, so the browser, which is the client, is actually going to send this data to, using a Vega specification. It is going to actually send this JSON file with Vega specification using the MapD connector to the back end. Now the data is already resident in the GPU memory, and using Vega we basically render it into basically the visual space, and then we create a PNG and we send back the PNG back to the browser for rendering. Now for basically display. Now this all happens in milliseconds, and so you get very smooth interaction with large amount of data. Now there are many use cases for MapD and operational analytics. Again, every day we hear about cyber crimes, and definitely that's a huge use case where you really want to analyze your data and in real time. We also had a lot of success in advertising. There are customers who are using MapD in advertising. There's also in telco, we have Verizon as one of our customers. So basically they do over-the-air advertising to basically find out all the iPhone devices, and then so that they can send in real time some advertisement. And so for them, they are actually getting like about 200 million rows per day, and with the tools that they were using before, it was taking hours to get a response, whereas with MapD it just happens in milliseconds. So so that's one of our very good use case. Again, we also are working with companies like H2O, Anaconda, to basically who are all running machine learning on GPUs. Now, instead of basically transferring the data from GPU memory back to CPU and again back to GPU, we have a consortium called GoAI, where we are working with these companies so that the data stays in GPU memory. And what we do is we don't even do a copy. It's basically zero copy, right? We just pass the pointer for the data frame from MapD to H2O to do its machine learning. And we will look at some of the samples that I'll do after I show you some analytics demo. Now, geospatial is also a big use case for us. We also have a new 4.0 release that's upcoming that will support a lot of the SQL operations on geometric, like polygons and lines and things like that. We have a slide on that later. So let's get to some demo time. Now, before I jump to my demo, let me we spoke about this the MapD immerse, where we are doing like some browser rendering of some of the simple charts, and then we do the complicated like a point map and scatter plots in the back end. So I just wanted to give you a quick peek into Vega, how it looks. So this is a JSON file, which is basically specifying. Here you can see that there's actually an SQL statement which is actually getting the data, and then you're specifying how the data needs to be rendered. And for example, in this case, we are saying, hey, draw blue circles of a certain size. Now, for example, you could actually simply change this to a square and change from blue to red. and we should see that. Now, this is happening on a large data set, but the response is coming back as a PNG back to the browser. So, pardon? This is about 2 million. Yeah. Now, but we're going to jump from million to a billion, right? Hello. And this is, you can all try this at home. Unlike a lot of advertisement, don't try it at home. I want you to try this at home. Also, after my demo, I'll also show you how you can all go on to the cloud and without any credit card actually get your own GPU instance in the cloud, and you can start playing with MapD today. And we'd love to hear your stories. We have an office hours. Myself, Emily, and rest of our the team will be there to answer questions. So I would highly encourage you. I'll put some URLs like join our forum, get your own GPU instance in the cloud. So in this particular case, I've gone to mapd.com. So if you go to mapd.com/demos, you see a bunch of interesting data sets. And you can actually click on any one of them to see. You can actually change this by, say, clicking on this gear, and you can make new charts, but you cannot save it. This is actually, you can apply and it'll be gone after you refresh, right? So in this particular case, you have 1.1 billion records. Now, as I was mentioning before, we don't pre-aggregate or pre-index data, right? It's all raw data that's sitting on MapD, columnar database table, right? And then we just apply, based on the filtering that you do, we are going to apply these SQL operations in real time. So in this particular case, this is from 2009 to 2015. These are taxi rides in Manhattan. And so we have a point map. Now, a point map is typically constructed with, longitude, latitude, and then you can put some kind of a measure. In this particular case, we are using the color for the different borough names. So for example, if you got the ride picked up from Manhattan, Queens, Brooklyn, you have different color, right? Now, likewise, we have the trip distance and the number of records, and so this is the number of miles, and we have a line chart which basically has the time and the number of records. And likewise, we also have the mode of payment as a bar chart. So you can see the number of people paying cash is more than the people paying by credit. Now again, this is 2009 to 2015, so it's old time, right? And this is all taxi data. It's not Uber or Lyft. So now, just to kind of show you, we have these 1.1 billion records. Now, what if I go and try to highlight over here, more on 2015, and you'll notice that now the credit card payments are actually more than cash. And all this happened almost instantaneously. We went and dug up about 234 million records for 2015. So, and you can actually click on that, and that takes away the filtering. So what happens is, anytime I click on any of these attributes, for example, if I click on credit, it immediately applies that where operation on every single chart and on all the data. And like I mentioned before, the simple ones get rendered locally on the browser using JavaScript D3 APIs, whereas the complex ones get rendered in the back end on the GPUs, and then we get a rasterized image to the browser. Now, you can actually go and also zoom in to, let's say we zoom into JFK. And as we are zooming in, you notice that all the other charts are also getting updated, right? And we notice based on the color that most of the, the borough for the pickups have all basically come from Manhattan for JFK. Now, if we Yeah, this is my browser.
Is this the regular interface to the tool through the browser?
That is correct. So Immerse works on a regular browser. So you can connect to port 1992. Again, this is that's the default. You can always change it, and then the browser will then talk to the back end.
So this interface specifically, do I have to write JavaScript to create this interface into the data?
No, you can actually simply, it'll come as a blank screen, and I'm going to show that in a minute. So yeah, because this all looks very magic, right? I'm saying I have 1 billion records, and then I'm just clicking and it's all changing. But what I'm going to do next is actually take Google Analytics data, right, from a live website, and then we'll create the charts, And any other question? Yes.
So I'm a little confused. You say the back end produces pings, which the front end renders. But I also saw that you moused over it, and you could do, looks like you could do point identification. I was wondering how that works.
The point?
Well, you have data.
Uh-huh.
Am I able to mouse over a particular data point and get label information, for example?
Yes.
And so if it turns out you've got pings that are rendering, pings are it's the entire screen, then how is it that you're able to go on and identify particular points? I'm a little confused about that.
So you actually, those points are actually pre-labeled. Like if over here, there's a pop-up box where you can actually add columns. So for example, I can...
On the front end, you want to basically render 1 billion points inside this graphic. If you have 1 billion points in the browser, that you're mousing over to go and produce these labels?
We are actually creating those billion points in the backend using Vega, and that actually produces a PNG, and the PNG gets sent over to the browser. So as I'm mousing, the mouse location is sent back, and that's how we're able to find out what that location is.
So
Yes.
you change the color, right, on the screen.
Uh-huh.
So if it is a PNG image, how do you change the color? So you said like initially it was blue, you changed red. So
Okay, that was basically your Vega editor. That's part of the JSON.
it's not an image, right? That's not actually.
Yeah.
Okay.
So Vega is basically, it's a spec. Basically, you have a data, and then you want to render it on a visual plane, and then you describe how you need to render it. What is the shape? What is the color? The different attributes, and then it basically then gives you a PNG image. Yeah, right. I just wanted to kind of show that also to kind of give you real context. And this is something that you can also try back in, because you may not want to use the Immerse, in which case you can simply use the Vega to create your own UI.
What happens when you overflow the GPU memory?
Excellent question. So the question is, what happens when you overflow the GPU memory? And I will show you. So that was actually my next slide. So as you can see, GPU memories are, of course, we're talking about, when you have multiple GPUs, you can go about 256 gigabytes, right? But then in terms of the CPU memory, you can have terabytes. But of course, so what we try to do is keep most of the hard data. So as you are querying the data, those columns are being kept in the GPU memory, but obviously if you, there will be a situation where you cannot fit it in, and then there is a setting in the JSON in configuration where you can say you can use CPU in case it doesn't fit in the GPU, in which case it gets demoted to the CPU. So your query will still run, but slower. Yeah. Okay. I think what we'll do right now is actually run. Yeah, there's one more question. Okay.
Sorry, I was just wondering how much of a hit would you take though if you have data transferring from CPU to GPU? If you run tests where you overflow the GPU, how much of a performance loss do you get?
I mean, it's going to be basically proportional to how much of the data has gone to the CPU memory, because it is going to be in orders of magnitude slower on CPU. So typically all your querying and response back will be in milliseconds if it's all sitting in GPU memory. But yeah, once you hit the CPU memory, you could probably cross over into the seconds. Now there is an excellent document on basically we help you size the kind of deployment that you need to do, whether it be in the cloud or on-prem. We have identified a number of system configurations, and this is all basically math, right? You may have 70 or 80 columns, but how many of them are going to be queried, and what's the size, what's the typical data set size, and you can have your GPU memory to make sure that it all fits in. Okay, the next thing I wanted to, because this is a canned demo, what I like to do is real stuff. So how many of you run, like say web analytics or familiar with Google Analytics? Okay, I see a few hands. Now Google Analytics is actually a much smaller data set, but if you use something like a MapD, you can actually go and grab a lot of data for many years, and also combine it with other say marketing or sales data, and you can come up with basically a very multidimensional view of your whole basically marketing and your web activity all in one dashboard, which may actually give you some really useful nuggets. So let me so I'm going to actually I wrote 2 blogs on this topic, so this is something that you can Google. You can just simply say MapD space blog space Google Analytics, and you will see the part 1 and part 2 of this, and there's actually a step-by-step guide on how to use MapD. So once you go home, fire up this MapD instance in the cloud. This is actually a very good exercise to go through as a data set to ingest data and also render it as create a dashboard. The first half actually talks about how do you create a certificate, because that seems to be the big thing, because you want to be able to have a Google certificate through a service account that you can then use as part of the Python. So this code has been written in Python. I basically started off with some code from Google, and there's another gentleman called Ryan Prasky on the web that I found. Very useful code from which I started, but then I expanded on it. And so once you create the certificate, the assumption here is, hey, you've created the certificate, then what you do is you install Python. You have code for both 2.7 as well as 3.6. So you can choose whichever version you want. You can, after you install the Google API Python client, MATLAB, Matplotlib, Pandas, and then PyMapD is our Python library API for interfacing with MapD. And then you can git clone the Git from github.com, MapD, Google Analytics.git. Okay, so so I've already have that code downloaded over here. So when you download, you'll basically you'll see your MapD underscore GA underscore data.py. You have the MapD underscore GA data data.py. That's the main file. While we are running this code, I will quickly go through the code. But in the meantime, once you do a git and get the code, one important thing is this client secrets.json. So this is important. This is the certificate that we talk about in the blog that you need to go and create from your Google account. And it'll download, it'll have some funky name with a bunch of digits.json. Just rename it to client underscore secret.json, okay? And put it in the same directory. And then what you do is, I think I already ran it over here. I'm going to do that. And then simply run Python So what are we trying to do here? So we have mapd.com as a website, right? So I want to just grab some analytics information, So I'm going to run the code, and what it does is on the website there are multiple views, and so it basically shows all the views to which you have access, and then I can just select the view that I want. In this case, I just want to go to the live website, MapD website live site. So I'm going to pick number 14, and by default the code just grabs the last 30 days. Now if you have a very busy site, it's still a lot of data, and now Google also has a limit, like you can run your data for, like, say, depending on what the web traffic, it's few hundreds of thousands of rows that you can get at a time, but not to worry. So what you can do is run this code over and over again for different intervals. So I typically run it for every quarter and go back a year or two, and then I do an SQL copy to MapD, so that it keeps getting added to that website, right? To the table, so it gets aggregated as you are copying to the same table. Now in this particular case, I'm going to just, because we don't want to be here all night, I'm just going to run it for a very short time. I'm going to run it from March 30th to 2018 March 5th. Now that was the around that time we actually launched our MapD cloud, so I want to see if I can see that visually, right? So March 30th to April 5th. So let's click that. Now the next question says, hey, if you have an instance, now this applies if you have an instance that you have shell access to, because that way I can then download the data and also copy it at the same time. Now you don't have to do it, you can actually copy it. What I'm going to show you is we're going to use MapD immerse to copy the data, and so you can simply hit enter. So at this point it's going and trying to pull the different pieces of information. So as you can see, it's getting data, hour, minute, longitude, latitude, landing page path, network location, and then it's getting all the other dimensions, because Google also has some limit on how many attributes you can pass at one time. So it's grabbing all the other things that I thought was interesting, like the medium, the source, and then the AdWords and things like that. Now, so if you look at the data, this is where we have the key dimensions here, and then all dimensions. So if you are interested in other stuff, you can either add more or you can replace some, right? So you can go and edit this file, and it's a fairly straightforward Python code. And the utils.py, I basically have, functions where, how to connect to MapD. So this is where we are using our PyMapD API to connect to MapD, and how do you drop a table, how do you create a table. So this is where how you basically specify the DDL for the table, and if we had specified all those server information, we would have simply done a copy, right? So we would have just copied the CSV file over to the table. Now let's go back to our screen to see if the thing completed, and sure enough it completed. And what it did was it basically created a MapD website livesite.csv.gz under data folder. And if you look under data folder, you see a bunch of CSV files. So for each of those different dimensions, it created a CSV. And if you look in the code, there's a merge function. So what I'm doing is I'm basically using the data frame and doing a merge so that I create a big table so that all those fields are there in a single table. Okay. And finally, I wanted to do a GZ so that way it will be faster for uploading to MapD. Now, I have a MapD instance running. This is my Azure instance, somewhere over here. Okay, so I'm going to, so I have a number of tables here. So this is what I said, I ran it for several quarters, and that's as you can see, it's about 1 million records, right? This is for 1 year's worth of data. Now, but now I'm going to import. So I pointed my browser at, on port number 9092, and then I go to the data manager, and over here you can click on import data. And then you can click on the plus sign, or you can drop it. Then you can go to the data folder, and you should see the .gz file. You can choose that, and it brought in the file, and you can say import files. Now it's kind of important to make sure that all the different, it automatically detects the different, data types. But it's a good idea to kind of visually inspect and make sure that it got it all correctly, okay? And then you can give a name. I'm just going to call it as GA_test. And it saved it as GA_test2 table. And as you can see, the table has all these different fields from the date, longitude, latitude. Now you can actually then go to the dashboard. So this might answer your question, okay, how did we create this dashboard? Because that was already pre-populated. You can simply say new dashboard, and then you can add a chart. And now you have a choice of all these different types of charts that you can create. Now, point map is always very interesting. So more visual. So I'm going to click on that and go to the GA test 2. And it says, hey, it needs a longitude and latitude. So I'm going to pick the longitude. I'm going to pick the latitude. And in terms of the size, I'm going to say page views, right? And now I can also give a color. Now I want to see how the different people came to basically the website, right? So I'm going to pick say the medium, and there was a question about how does it know as I'm hovering over the map. So I'm going to say country, and also I'm going to pick the city, right? And then I'm going to say apply. So at this point we have a point map, right? Now it's very important that you also do a save, because you've just done an apply. So you need to give a name. You can also give some very meaningful, instead of your field names, you can make it more, descriptive. And so now you can see how many people have come through Medium was set to CPC. How many people know what is CPC? Okay, so it's cost per click, right? So that's basically actually these are the visitors who have come to your website through the AdWords. So there are a number of ways that people come, right? Either through AdWords or through manual campaigns, where you are basically, it's a user-defined campaign. They can come organic, which means they have come through a website, right? So, and so then it's basically you get an organic, or it could be referral. So referral means they have come to your website through another website. And also it could be direct. That means the person already knows your website URL, either it's a bookmark or somehow, and he just types it, in which case it is tagged as direct. So, and as I zoom in, you can see that I can just hover over any point and it immediately says, hey, it's Santa Maria in Italy. So now what makes it more interesting is as we populate this with more charts, right? So that way we can see the cross filtering happening. So there is an easy solution too for that. So what I've done is I've saved a template of the dashboard that I created for my blog, and I put it on Amazon. So what I'm going to do is I'm going to log in to this computer, right, to this MapD server. So I'm going to just log in to the MapD server, and and I have on S3 a Google Analytics sample dashboard template. So I'm just going to grab that. And this is actually a JSON file in a compressed format. So it'll look pretty mumbo jumbo. But then you can actually pipe it through JQ, and it'll make it more interesting to see. Now, over here, if you look at that, I have put a bunch of placeholders like sample table name, and also I have similarly for the dashboard, a sample dashboard name. So what I'm going to do is simply use sed to replace it. So the table name is GA underscore test 2. And I'm going to call the dashboard as GA underscore test 2 underscore dash, right? And so let's go ahead and do that. Yeah, first I'm going to copy to another file to make sure that I don't mess with this, the original, and then I'm going to do sed. So in here I'm going to change it to GA, replace all sample table names to GA test underscore test2. And likewise, for the dashboard name, I'm going to change from test1 to test2. Now, at this point, one of the things I wanted to show is once you log into the MapD server, you have access to the SQL through MapDQL. And I'm going to log in. You have to specify the database name and the username and the password. And then what I'm going to do is import the dashboard. Now it's important to use the same name, which was GA underscore test2 dash, and then specify the name of the file. So once I do that, I can go back to our dashboard. So let's go back to dashboards, and we should see GA underscore test2 underscore dash. So if I click on that, boom. So we've taken all the, almost like 20,000 records, and then we are rendering it, based on this template. Now you can very easily see from the timeline that there was indeed a big bump up on April 2nd and 3rd because of our announcement. And now if you can click on organic, you can also see that a lot of the traffic came through search engines, right? So you can also do some fancy, so as you're zooming in, zooming out, you're basically applying those filters, right? Now, you can also apply global filters by just going over here, and you can say add filter, and then it says what is the source, and then you can, for example, I can say pick medium, and then you have a whole bunch of operators like contains, equals, not. You can also have our own custom SQL too. So I'm going to say contains. Now I want to find all the traffic that came directly, right? So I'm going to say none, because that's what, so when a traffic comes directly, you'll have a none in the medium field. And in the source, you will find, you can have a value of direct. And now you can see that all these visitors came directly, and many of them came to mapd.com or announcing MapD Cloud, right? So any questions? Yes.
What is the cloud instance you're using?
That's a P2, on Amazon, and actually I kept an Amazon instance. Yeah. So basically, again, it's free for you during the trial period, and it's the P2 extra large, which has 1 GPU count. Yeah.
Give us details of the trial period.
I beg your pardon?
Any details of the trial period, like what's the length of the trial period?
By default, it's 14 days. Now again, once we, if you want to extend it, we'll definitely be supportive. So that should not be an issue. And while we're talking about the trial period, you can simply go to mapd.com, just to the main website, and there's a try cloud right there on the top. And you don't have to do anything other than enter your valid email ID. There is no, you don't have to be bothered about any pricing information. There's a lot of information if you look in terms of pricing on the website. But again, I would say highly encourage you to first go and try and see if it really works out for you. And we can definitely work with you to keep the subscription going. Yeah.
I was wondering how many genomics customers you have.
I'm sure we do, but I'm sorry. In this particular role, I'm not in sales, so I'm not directly plugged into all the different accounts that we're dealing with. Yeah. But would love to. Genomics is a great use case. Yeah.
Well, could I see one?
Maybe it's there in the demos. I don't know.
I'll go there.
Okay. Okay. If you have no other question, then what we'll do is we can quickly look at the other slides. So as we were saying, MapD's performance is, it tries to keep most of the hot data in GPU memory. Now, this is also one of the strategies that most of the machine learning tools are doing. But unfortunately, what happens is, even though you have on the same platform, you have different machine learning tools running along with MapD. As the data is going between, say, Anaconda and H2O, this machine library, the data is getting copied back to CPU. And so you're basically losing all the performance that, gain. So that's one of the reasons why MapD, H2O, Anaconda, basically Continuum, basically we all got together and came up with the Go AI, basically Open Analytics Initiative. The whole idea here is zero copy, make sure that all data stays in GPU, and so that way basically your whole, so MapD kind of fits into the machine learning workflow, where you can basically and this whole data frame that we defined is based on Apache Arrow, so which is again a columnar storage. We have a library called PyGDF, and so if you look at this whole machine learning pipeline with data being initially ingested into MapD, and then you take out the tables, you basically are doing all your data preparation and discovery and feature engineering all in this data frame that you read from MapD, and then you pass it on to say a GLM library in H2O or XGBoost, and you can run your test and train, and then you can again create your prediction data set and then again back ingest it into MapD to basically see how visually does it, what is the correlation and things like that. So there are good examples. That's all open source. Again, you can simply go to GitHub GPU Open Analytics. So GPU Open Analytics is the GitHub repository for Go AI. You'll find examples over there, and basically it'll show you how to get a data frame. How do you populate a data frame, a PyGDF data frame with data from MapD, and then it also basically has an example where it shows you how you can do different operations with the data frame. And then there's also an example with passing it along to the machine learning libraries. So there's extensive. There's also MapD, MapD-ML-demo. Hopefully these slides are going to be available to you, so you should be able to get it. Yeah. And of course, these are all on Jupyter Notebook. In fact, I kept some links open. And what we have coming early next month is our 4.0, which has support for geospatial data types. So supporting data types like points, polygons, lines. And so now you can do SQL operations on all these geospatial data. And we actually we've been working with many experts in the field, including Michael Flaxman, who's from Geodesign Technologies, and he's collected all the LiDAR data from the state of Florida, and also he has some other data sets from Lake Tahoe, and we're going to do a presentation in Phosphor-G next month. So stay tuned, and again, this beta is also available in case this data set is interesting. We'd be happy to provide you an early access to that code. So the question was, is this specific to any particular GPU? And basically, no, this is any general purpose, GPUs should be fine.
But this demo was with the AMD Veda.
The demo that I showed on Google Analytics? Actually, I have an Azure instance running, and
Vega you mentioned, Vega.
Oh no, Vega is basically a library. It's basically a visualization specification, which allows you to send a data and then also some descriptors via JSON how the data needs to be rendered. Yeah, we can talk after, but I just want to make sure that there are some interesting links over here. So a couple of action items. A, register in the cloud, get your own GPU. And number two, join the forum. So we have a community. So again, MapD core technology is open source, and we want active members to contribute to our innovation, and we want you to participate. And so join the forum, and as I mentioned, there's also /demos where you can actually see some other demos. There was a gentleman who was interested in, so as we find some interesting demos, we'll keep adding that, so. Anyway, now I'm open for any Q&A, yeah.
How about Amazon Redshift? What would be the connection between MapD and Redshift?
Amazon, yeah, Redshift. Actually, there is some, so the question is, what is the connection between Amazon Redshift and MapD? Now, isn't Redshift more like an in-memory database?
It's also a columnar data warehouse.
Right. Now, the only point is most of these columnar in-memory databases including Redshift, they have been designed with more CPU centric. The big difference here with MapD is it's the only database that's been kind of built with just GPU in mind, even though we can run on CPUs. So when you have MapD running on GPU, we are 100 times faster than anything out there. And you can look for some MapD space performance. And actually, there's some very interesting data on, actually, I think I did a cut paste of this. So you can actually see the blue is MapD, and this y-axis is the query response time. And you can clearly see that a lot of the in-memory databases, they basically pale in comparison to MapD. It's just been architected that way. Any other question?
What's the largest multi-GPU configuration that you can run?
I think we are you can go up to 8 GPUs per server. Yeah.
Do you run on the DGX?
Absolutely. And if you can send me an email, I'll be happy to share some details. Like I have the there's a reference, configuration guide. We talk about, our DGX configuration over here, So there's plenty of, guidelines on what exactly you can get depending on, your price.
Now, on the other end of the spectrum, can you just run it on your
Mac.
gaming?
Yes, absolutely.
machine?
Yes, absolutely. Yeah, it can run all the way, from, yeah, and you can even run it on on a regular CPU. You can just download the code and run it. There's also a Docker image, so you can run it as a Docker. Again, you won't see that kind of a performance, but at least you will get a feel of the product. Yeah, thanks a lot, and thank you for the opportunity. And